Okay, let's talk a little bit more about this whole idea of a logarithm and log functions. So if we see log base a of x equals y, what this means is that a raised to the y equals x. And I like to always point out this thing which I call the loop. This means a raised to the y equals x. If you remember this little loop, it'll be very helpful throughout the rest of this chapter. Now, we do have some restrictions. Remember, when we were defining these exponential things over here, we had a restriction here that the a had to be greater than 0 and a could not be equal to 1. Well, it turns out that for logs, we have the same conditions. The base down here must be greater than 0 and not be equal to 1. We also have one additional thing. Remember that with any exponential, your result is going to be a positive number, meaning that if you were to graph an exponential function, remember it looked like this, all of the things that come out of an exponential function are always above the x-axis. So whatever comes out over here is always going to result in a positive number. That means when you go back to the notation here, we have one more restriction, that the x here, okay, must be greater than 0. In other words, you can never have a negative number inside of a log. Okay, very important. Now, let's see if we can evaluate some logs. So let me give you a couple of examples here. I'm going to leave this here so we can refer to the loop thing. Let me ask you to find what log base 2 of 8 is equal to. Okay, so what is that equal to? Well, this is equal to something. I'm going to call it y. All right, so we're trying to find out what y is. Now, this means that 2 raised to the y must equal 8, right? 2 raised to the y must equal 8. There's the loop. So I write that down. Now, can you think of what power you'd raise 2 to in order to get 8? Well, we can just think about it, right? 2 squared is 4, 2 cubed is 8. So the answer here should be 3. Another way to look at that is to look at the right side and realize that 8 is just 2 cubed, right? Since the left and right hand sides have the same base, this exponent must equal this exponent. So therefore you can conclude that y is equal to 3. So the answer back here, log base 2 of 8 is equal to 3. And you can just check real quick, do the loop, 2 cubed is 8. Let me give you another one. What is log base 2 of this time, we'll say 1/4? Okay, what's that equal to? Well, again, it's equal to something, I'll call it y. Now I use the loop. Okay, so the loop tells me that 2 raised to the y must equal 1/4. Okay, it's not 2 times y, it's 2 raised to the y. Now when you look at this, it may not be obvious to you, right? 2 to what power is 1/4? Well, that isn't something that clicks automatically. So what we do is we look at this side and we see if we can see a power of 2 over here. Well, what we realize is that the denominator is 4, and 4 is 2 squared, right? Now, using the property of exponents, remember this property of exponents, that if you have x to the negative n, it's equal to 1 over x to the positive n. Now, usually if we have a negative power, we write it like this. But now what we're going to do is if we see this, we're going to write it as a negative power. So this right here is 1 over like something to the n. We're going to rewrite the right side as 2 to the y equals what? 2 to the negative 2. That will bring this up into the numerator. Now we have the same base, and therefore the exponents must match. So y must be equal to negative 2. So the answer here is negative 2. Okay, you getting the hang of it there? Let me try another one. This will be our last one. Okay, what about log base 10 of, let's just say 1,000. We'll make this pretty easy. All right, so you always want to check with logs that your base is a number that's positive, right? Not greater than 0 and not 1. And you want to make sure that what's in here is greater than 0. So it is. Now we just say this is equal to y. And now what we want to do is say, okay, use the loop. 10 to the y must equal 1,000. Okay, now we can say I need to try and figure out if this is a power of 10. So this is 10 to the y. I'm going to make this what? 10 cubed, right? 10 cubed is 1,000. So y must be equal to 3. And therefore your answer is 3. I said that was our last example, but I'd like to do one more for you. Okay, let's try log base 4 of 8. All right, this one's a little tricky. This is equal to something, I'm going to call it y. Now that means 4 raised to the y must equal 8. I'm using the loop there, okay? Now, I try and write this as a base of 4, but I can't, right? 8 is not 4 raised to some power. So I'm kind of stuck at this point. So what I need to do is figure out if these two bases, 4 and 8, have anything in common. Well, 4 is 2 squared, right? So writing 2 squared to the y is the same as 4 to the y, because 2 squared is 4, and then all of that to the y. On the right-hand side, 8 is 2 cubed. Okay, we're getting there. Now what we're going to do is use the property of exponents that says this. If you have x to the m raised to the n, you multiply the exponents. Okay? So here I can take something to a power, all of that to a power. I multiply these two powers. So it's 2 raised to the 2y equals 2 to the third. So now I've created the same base, therefore this must equal this. So I write that down. 2y must equal 3. Divide both sides by 2 and you get y is equal to 3/2. And that's your answer. So you can put that here. Y is equal to 3/2. And that's it. You can check your work now if you like by doing the loop and verifying. I'll do that real fast. We're saying 4 to the 3/2 is equal to 8. Now is that true? Well, 4 to the 3/2 means that you're taking the square root, because that's what the 2 means, of 4, and then you're taking that answer and you're cubing it. Now the square root of 4 is 2, right? So this is 2 cubed, and of course that's 8. So yes, it does check. All right, now what we're going to do in the next couple of videos is actually, instead of working just with logarithms, we're going to start looking at logarithmic functions and how we would graph them.